Okay, our next set of speakers focuses on, is a diverse set of speakers focusing on physical conditions and how they affect the ecosystem, as well as what zooplankton choose to eat. And so,
hello everyone, I am Vimal Koul from University of Hamburg and Max Planck Institute, Hamburg. The question I pose for my PhD research is, do marine ecosystems in the North Sea respond to changes in the subpolar gyre circulation? And what motivates this question is earlier findings that oceanic anomalies in the Rockall Trough pose a huge constraint on the primary production in the North Sea. So we look into physical variability in the subpolar gyre. Okay, so what we do is we run a climate model for 156 years, and here I show you the composites. The contours here are the circulation. So this is when you have a very strong gyre state. You see this gyre has an east-west orientation, and it throws a lot of fresh water towards the eastern side. On the other hand, when you have a weak gyre, the gyre is a bit contracted, and you have a lot of subtropical saline water going into the North Sea and the Nordic seas. So this is the gyre variability, which has impact on the oceanic inflow to the North Sea. So if you go a bit further and do a water mass analysis, a volumetric water mass analysis in the Rockall Trough, in the Faroe-Shetland Channel, and in the northern North Sea. So the second row here. And these are the composite differences between a weak and a strong gyre state. So what you see here is that when the gyre is weak, you have a lot of warm and saline water in the Rockall Trough compared to when the gyre is strong. So this variability is present in the Rockall Trough. But when you cross this Iceland-Shetland ridge, which has a depth around 600 meters, still the saline signal is there, but the difference in temperature is lost. So these regions are a bit shallower, so the winds take up a lot of heat from the water, but the saline signal is still maintained. And when you go into the North Sea, so still this saline part of the signal is there. So based on what the gyre is doing, you will have a saline regime or a fresh regime in the North Sea. So these teleconnections are important when we go for, when we want to develop predictive capabilities emanating from the subpolar gyre. So the next part is to look into the variability in the nutrient flux, because most of the nutrients are here on the western side of the subpolar gyre, and these subtropical waters are nutrient limited. So if you have the seesaw in the nutrient load as well, and then it will affect the primary production in the North Sea. So thank you.